So Mario sat on a improbable brick platform. Mario has a weight, and Mario also has another force acting on him, and that is the force to block pointing upwards, so the normal contact force. Now these two forces together make it so that Mario has a zero resultant force, so he is not accelerating in any direction. Mario then decides that he's going to jump off the block, because that's what Mario does. And the moment he falls, he starts to fall, before he picks up any vertical speed, he still has the weight acting downwards, but he doesn't have any air resistance acting upwards, so he accelerates downwards. And as he does accelerate downwards, as soon as he starts moving, he then has air resistance acting upon him. And it's small to begin with because he's not moving very quickly, but the faster he moves, the bigger the air resistance gets until it's equal to his weight. Now at that point, we have Newton's second law, F equals ma, force equals mass times acceleration. The resultant force is zero, so the acceleration is zero. So he's in equilibrium, obeying Newton's first law. No resultant force, no acceleration, constant speed. So this is terminal velocity. Where the downwards force and the upwards force are equal, there's no acceleration, so it doesn't get any faster or any slower. So he's falling, and that's the result. So, scenario 2, parachute Mario. Why will a parachute save Mario's life? Well, let's put two side by side. They both have the same weight because they're the same character. They're both falling, but because parachute Mario has a larger surface area because of the parachute, he has a slightly bigger air resistance. So as time passes, after 1 second, Mario with the parachute has a much bigger air resistance than non-parachute Mario. And then after 2 seconds, again, after 3 seconds, again. Now, what we can see now is that now parachute Mario has equal upwards and downwards forces, so equal weight and air resistance. So what's he going to do? Well, he's going to stop accelerating. Non-parachute Mario, not so much. He's going to carry on accelerating. Now, it looks like parachute Mario goes up when he opens his parachute. Well, in actual fact, that's not the case. What happens is that non-parachute Mario increases his speed downwards, whereas parachute Mario slows down. So it's a case of, it looks like parachute Mario travels upwards. In fact, he doesn't. It's just a sort of weird optical illusion. After another few seconds, normal Mario is now at his terminal velocity, but he's been accelerating for longer, so he's now traveling faster than Mario with a parachute. So the result of that, same result and slightly different result. So parachute helps Mario to survive.